let's have a look at some definite integral problems. So let's just think about what the definite integral, the signed area under a curve, represents. First, we're going to draw a graph of the signed area represented by this integral. Okay, so this is a line. The intercept is 1, 2, 3, 4, 5, right? And the slope is 2. So if we go 1, 2, 3, 4, let's see, for every 1 we go over, we go down 2, right? That's the slope, so it goes down 2, down 2, down 2, down 2. Let's see, so I better have, that's -3. That's not looking very straight. Yeah, use your imagination. That's really straight, I'm sure. Maybe I'll straighten out my curve just a little bit. Okay, so remember this goes through the points, in particular 2, 1, right? If you put in a 2, the output should be 1, and it goes through the point 4, -3, right? And that's key because we care about the signed area between x equals 2 and x equals 4. So what happens? Well, somehow this triangle over here is positive, and this triangle over here is negative, right? So that's the graph. Now we need to compute geometrically what that signed area is like. Now, we could, I guess, calculate the area of that triangle and then subtract the area of that triangle, or we could come up with canceling triangles. I think those two would cancel and calculate this area. Let's use the first method. This right here is 1/2 wide and 1 tall. So that area is, let's see, 1/2 base times height is 1/4, right? 1/2 times 1 times 1/2. What about this area down here? Well, that length there is, I guess, 3/2 from 2.5 to 4. So 3/2 wide, 3 long, right? So I have 1/2 base times height. What is that? That's 1/2 times 3/2 is 3/4 times 3 is 9/4. Okay, so 1 minus 9 is -8/4. That's -2. That's what the area is going to be there. The signed area, obviously, because more is negative. What about this one? Same problem, but I need the graph. 2 cosine. Now, that means the amplitude is 2, so it goes from 2 to -2, right? And if you remember, it has a period of 2 pi. So if I was going to graph that, pi, 2 pi, and maybe you'd put in 3 pi halves and pi halves. Starts out at the peak, goes to 0, goes down to -1, but I'm stretching it, so -2 for this graph, up to 0, back up to 2. Now I'm looking at the signed area here. Well, this area is negative. This area is positive. Geometrically, those are exactly the same areas. This is negative, that's positive. So if I have this as area A, that's also area A, so minus A plus A. The signed area is 0. Well, that's real convenient, and we can do it geometrically. Maybe eventually we'd need a method to figure out what that area is A, but here we can just use offsetting areas to figure out that it's 0. Well, what if we know this? What if I don't know what the function f looks like? Notice you can integrate as t moves from 1 to 3. The way you notate that is just dt at the end. That area, signed area, is 5, but the area from 1 to 3, the signed area under g, is 2. What do you do here? Well, it turns out that if you know how tall this is, you can think about that definition. How tall should the pieces be for something that is twice as tall? Well, every rectangle is going to be twice as big. So essentially what you're going to get is you're going to get 2 times the integral from 1 to 3 of f of t dt. And if you have some height minus another height, you can break that apart too. We say this is linear. And I can just worry about this as individual rectangles as well. Put the rectangles together after the fact. This is convenient because I know all of these pieces. It's 2 times that signed area, which is 5, if you notice up here, minus 3 times this signed area, which is 2. So 10 minus 6 is 4. What about this here? Let's assume that the signed area under h of x from 0 to 4 is -1, and from 4 to 5 is 3. Now you might be tempted to draw h, but there are so many h's that could have this. I don't know what it is, but I want to know what the integral from 5 to 0. Notice that's going down the number line. So maybe the first thing that you want to do is you want to think, oh, I really don't like it going down the number line. I know that if I reverse that and go left to right on the number line, that's just negative that integral. Okay, so there's a negative sign there that you have to remember. Now, if I want to know the signed area from 0 to 5, that's the same as putting together the signed area from 0 to 4. Why am I using that? Well, because I happen to know what it is, right? Plus the signed area from 4 to 5. You can put rectangular boxes in that and rectangular boxes in that, then add them together, right? Well, this is rather handy because I know those two. This is -1, this is 3. So let's say that's +2. The entire thing is -2.